Welcome back to Advent of Code 2025, day 7. Ready to begin in a couple of minutes. These are what the overall stats have looked like so far. All right, so that problem wasn't too bad in the end. Looks like 3 was the harder one. Overall, it's been easy though, relatively. All right, just wait for this to unlock. Okay. Oops. Oh, just knock my camera out and there we go. All right. Here we go. What's it gonna be? Dijkstra. Day 7 laboratories. You thank the cephalopods, good old cephalopods, for the help and exit the trash compactor. Finding yourself in the familiar halls. This is the one with all the guards. The North Pole Research Wing. Based on the large sign that says Teleporter Hub, they seem to be researching teleportation. You can't help but try it for yourself and step onto the large yellow teleporter pad. Suddenly you find yourself in an unfamiliar room. The room has no doors, the only way out is the teleporter. Unfortunately, the teleporter seems to be leaking magic smoke. Really? I've never heard people call it magic smoke. Just smoke. Alright. Since this is a teleporter lab, there are lots of spare parts, manuals, and diagnostic equipment lying around. After connecting one of the diagnostic tools, it helpfully displays error code, "Oh no!" which apparently means that there's an issue with one of the tachyon manifolds. You quickly locate a diagram of the tachyon manifold. Tachyon beam enters the manifold at the location S. Tachyon beams always move downward. Tachyon beams pass freely through empty space. However, if a tachyon beam enters a splitter, the beam is stopped. Instead, a new tachyon beam continues from the immediate left, from the immediate right of the splitter. Okay. To repair the teleporter, you first need to understand the beam splitting properties of the tachyon manifold. In this example, a tachyon beam is split a total of 21 times. How many times will the beam be split? Alright. Fine. So do we want? Okay. So like a grid like yesterday's. For line and read lines, just do map dot append line dot strip. Hello DAJ. The coding has been pretty good. The last 6 days have been on the easy side relative to previous years, which is suspicious. We might get a hard problem soon because we're over halfway through the month now. It only goes until day 12. Right, so pop each of these on the map. We probably want to look out for the S. Let's wait till 14 takes like 3 days. Well, 12 will be the last one. So if we check for S, if S in line, it's not the whole month, no. It's just 12 days. I think Eric couldn't, it was just a lot of work for him he spends literally months of the year doing this, so he had to reduce the amount. So it goes from day 1 to day 12. And that might be what it does, how he does it from now on. Also, they got rid of the global leaderboard because people were cheating too much. People were, and that's a good decision. I've been saying for years he needs to get rid of it. It's just like there's no point having it if the top times are always people who've used AI to solve it. We still have individual leaderboards, and that's what people use. But the global leaderboard is gone. Right, S in line. What am I trying to do? Okay, we want to store start equals start equals, let's just say I line dot find S. Okay, so that's where the start is. That's all we need. All right. So when we've got this for row in map print row, let's see what this looks like. Okay. So we've got the starting position. Let's just check it. 070. Okay. So the beams carry on until they go off the end. All right, so we're trying to work out how many times. We don't want to duplicate work here, so we're with a beam. If the beam comes in from here, then it splits down to here. But if a beam also is coming from here, that also is the same beam. So we don't want to duplicate like recursion here. Is this a giant pachinko machine? Or Not quite, no. It's a laser beam that splits at each of these splitters. So there's a beam coming here, then it becomes beams here and here, and it becomes beams here and here and here, and so on. We can do this row by row. Just say, at row 1, where is the beam? It's here. Row 2, where is the beam? It's here. And row 3, yeah, we do it like that. So in each row, we maintain a set of positions where the beam is. And then in the next row, we look at all those previous positions and move them down by 1 and see if that hits a splitter or not. Let me look at the... Yeah, that should work. Okay, let's do that. So let's say... ultimately, what do we want? We want how many times will the beam be split? Okay, so that's just the number of splits we encounter. Okay, so beam points equals set start. We just put the starting beam in. So for row in range, so nm equals length of mat, length of mat 0. So we want to go to range n, but probably want to skip the first one because that's like dealt with. So we start from this row. So we create a new beam points. All right, so we go through all the beam points for ij in beam points. New I. All right, there's two cases basically. If mat I plus 1, the same j, is a splitter, do they ever have splitters next to each other? And what would you even do in that scenario? I don't think so. We can Control F this. Control F. No, doesn't happen. I'm not sure how you define that. Alright, so if it's a splitter, then new beam points dot add. So it'd be I plus 1 j minus 1 unless it's off the grid, so minimum maximum of 0 j minus 1. Does that even happen? I think we should adjust for it just in case, but I don't think it happens. We'll about it. We can assume it's an infinite grid. So that's that. Then we want to add J plus 1. And if there isn't a splitter, then we simply add... Stop spacing out my things. J. Just go straight. And then after we've added these new beam points, we do a swap. Beam points equals new beam points. And now what? We just count how many splits we saw. I'm guessing you updated your ID, which is why it's doing dumb stuff like that. What stuff is it doing? I think it's doing mostly what it was doing before. What, like autocomplete? Oh, that, yeah, it always did that. That's actually because I have like Python styling enabled, and this particular style that I'm using recommends spacing out. That I have to find the sheet and adjust it. I mean, for the most part, having a Python style autocomplete thing is actually a good thing. It does actually put a lot of things where I want them. On this particular thing, I just like not spacing out additions and subtractions, but in the style you're supposed to. Beam points equals new points. And that's it. But we also need to... Let's have a look. How many times will the beam split? But what if two beams join each other? So what do they actually mean by the phrase, how many times will the beam be split? I think they mean... how many times it hits a splitter. And that doesn't necessarily mean... You can't necessarily work that out from the number of beams at the end, because a beam might be split, but the two splits just join on with other beams, in which case it's almost like that split never happened. So, but that counts as one. So I guess we need to actually, each time we see a splitter, I'm just looking at their example. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Yeah, okay. It's every time, it's just every time we count one for every one of these, right? There can only be this, we don't have duplicates in here because it's a set, so we won't have this happen twice for the same beam. Okay, so result 1 equals 0. Apparently we've got ints. Ints have been sneaking into our beam points. Oh, that's not how you initialize a set. There we go. 1633. Correct. All right. With your analysis of the manifold complete, you begin fixing the teleporter. However, as you open the side of the teleporter to replace the broken manifold, you are surprised to discover that it isn't a classical tachyon manifold. It's a quantum tachyon manifold. Whoa, what a twist. With a quantum tachyon manifold, only a single tachyon particle is sent through the manifold. The tachyon particle takes both the left and right path of each splitter encountered. Since this is impossible, the manual recommends the many worlds interpretation of quantum tachyon splitting. Each time a particle reaches a splitter, it's actually time itself which splits. In one timeline, the particle went left, and the other timeline, the particle went right. To fix the manifold, what you really need to know is the number of timelines active after a single particle completes all of its possible journeys through the manifold. So there's the particle where it went left. So we're counting number of paths. This is a dynamic programming problem. This is a classic one. I've been asked this in interview questions multiple times before. So what's the solution? I think this can be done recursively, but you have to use memoization otherwise, because it's going to be an exponential number, but you don't want to count exponentially many paths. That'll take too long. So you count how many paths. So from a specific splitter, you want to know how many paths lead from it. Okay. And from the splitters at the end, that's easy to compute. The answer is 1. There's only one path. And every time you know a row down here, you can work out a previous row and so on, using dynamic programming. I don't see anything being hard here. Let's try it then. So what we want is a recursive function with memoization. Define, and we want, given a splitter, we just want to return num parts for a given splitter. Or given position? No, a given splitter. So let's say we feed in the splitter with an I and j value. So looking at the input, I guess we've got to look at these left and right paths. So left equals equals ij minus 1. Or should we just say left j equals ij minus 1. And we want to work out where that beam goes until it hits the splitter or hits the end, I suppose. So while Li is less than n, if mat Li, so we look at where we're on, so we're on the left path, and we look, and every time we see a dot, we just go down by 1. So if that is a dot, then we do Li plus equal 1. So out here, either we are now sitting on the next splitter, or we've rolled off the end of, we're one past the end of the grid. So if Li is n, or greater or equal to n, I suppose, that means the left count is 1. There's no splitting that occurs. We just go straight to the end of the grid. Let's just make it clear we're doing the left path first. Else, we do hit a splitter. And this is pointing to it. So we say left count equals recursive num paths from the splitter at Li Lj. So every one of the paths from that later splitter counts as one left path here. Now we just do all of this, but on the right. So we've got right I, right j equals ij minus 1. So we want right count equals 1. Paths right riij. So after all of this, we just return left count plus right count. The beam can go any of the left paths, it can go any of the right paths, and they can, even if it intersects, it doesn't matter because it's defined uniquely by the splitters it followed along the way. And the most important thing, though, is we need to what's it called again? LRU cache it. Is that how you do it? You just put that and we import LRU cache. And now we just print should automate this. I can see where the first splitter is, but let's see. Okay, so beam equals start. Let's see, BIBJ equals start. It's basically just this. I should have made this a method, like for finding the next beam or whatever, finding the next obstacle. Okay, so that should point us to the first splitter. Now we print num pods bi bj. Now I don't think it's actually LRU cache, because we actually want stop. I don't think that's actually what we want. Let me look it up. Forget. We don't actually want to use LRU cache. We want to use max size. Isn't this already max size equals none? Let me have a look at this. Is it default? Max size. Oh, it defaults to 128. How did I do this before? Hang on. No, there was a different... Have they changed how this works? Do you not just write like mem-wise or something? No. Alright, well we can do max size equals none, but I don't remember ever having to write that before. But if it's none, hello, Raiden Heaven. What's that? Within distance. Is that some sort of Euclidean distance method? I'm trying to remember how this is programming functions. This is distance check without using the get magnitude, which uses the square root. Oh yeah, so it gets the squared distance. That's quite useful. I shouldn't be using LRU cache, as I suspected. We don't want LRU, not least recently used. We want like a full cache, don't we? Still taking a long time. So it shouldn't ever be J. What are you making? I'm trying to solve Advent of Code. Let me post the link for this. Day 7. That is the problem I'm solving. It's a puzzle. Okay, so this is going on forever. That's not what I expected. So I've got a while loop somewhere that's not terminating. While li is an n. N is defined to be length of mat. Okay. While Ooh. One possibility is... Oh. Let's print bi. Make sure we've got the right splitter. Oh. This while loop is going on forever. bi bj equals start, right? Start is that. Oh, for fuck's sake. I didn't write the else condition here. BIBJ 070, that's not right. Oh, because it's an S, damn it. Oh, this is... Okay, whatever. bi plus equal 1. Just start below the S. Alright, try that. $270. 0, 1, 2. Okay, we're on the correct splitter. That's a start, I guess. Now. Oh, and it made the same mistake in each of these while loops. So this while loop, just do this in the safe way. Just say while li is less than n, and that right? So that is a safer while loop, less likely to get stuck infinitely. So we do this pattern here. but this is ours. And just do this as well. You need to keep track of what is above. Yeah, sort of. There we go. Wow, that's a big number. All right. But it was instant. That's the beauty of memorization. Let's see if it's correct. It's not correct. Okay. That is a bit too big, actually. Actually, I don't know if it's too big. It doesn't fit in the bar, though, so that's a bad sign. Alright. So, my worry is that they're defining path in a way that I've not taken it to mean. So let's have a look at what they've said. Exactly. It ends up on 40 different timelines. Wait, so how are they defining timeline exactly? Every time it splits, that's 2 timelines. Okay. So here, there'd be 2 timelines from here. 1, 2, but then they split. So you want to add all the timelines from the left, all the timelines from the right. Hang on. I feel like that's what I did. Okay, fine. So ij minus 1. Okay, it's probably a minor error then. I need to take 2 minutes break though, so I'll leave it on this browser screen. I'll just leave it on this description here, I suppose. Alright, I'll be right back. Okay. So, what went wrong? It's a huge number. That doesn't seem right. Seems like it could be too big, but let's just have a quick look at this before I test the test example. The left count. And the first splitter should be like so let's make sure, like, for example, this one is so that's I equals 140. J equals 1. So it should be 2. Yeah, it is. And then if we go one up, so if we go to the one up here, so 138012. Four. So that's splits 1, 2, and for each of those it can go 1, 2, 1, 2. 4. Okay, fine. Let's try the test example then. $128. Yeah, but it should be a power of 2, shouldn't it? Why? No. Only if every splitter hits a splitter. But if we look at the example, if every split, if we always keep splitting, so in this path here, this should just go off the end. So it shouldn't quite be... So these should be... 128. 40 different timelines. Okay. So we know the ones at the end compute 2. Something's off then. Maybe it's just like an index or something. Right. Oh, for fuck's sake. It's plus. That's why it's double. That's why it's powers of 2. Because it's just doing the left path doubled. Damn it. There we go. 40. All right. Alright, and the full thing. That's smaller, isn't it? Way smaller. Correct. Okay, we got it. Yeah, cool. Oh, not many people have solved it yet. Well, oh, actually, 3,000 is a lot of people. It's just these numbers are getting big now because a lot of people are catching up on these. Yeah, that wasn't really a hard problem. It's just kind of screwed it up a bit. Uh, yeah, people are doing it. Wait, am I on this list? Oh, I'm down here. I've solved it. These leaderboards take a while to update, don't they? Anyway, um, so we're building a. So this is the room with all the toilet paper or the paper rolls, not toilet paper, just paper rolls. This is like the cafeteria, I guess, and then this is wherever we are now. Where are we now? Tachyon room, the laboratories. What does the 1, 2, 3 mean? Oh, that's where we are now. It's like this is the teleporter room. Okay. Oh my god, why is the music just pause? All right, so that's it then. Good problem. That is a yeah, that's a good problem where you can't just um you have to use dynamic programming and you have to use the correct pattern. But it's a classic problem. I've seen that a million times. Um, not exactly in that format, but it's always some kind of pyramid structure. Not much to say about it. It's dynamic programming, use memorization. Python has it all built in, so it's really efficient. I mean, they could have asked for. Oh no, this was the best question to ask. Number of different paths. Okay then. Tomorrow, I don't think I'll be on time at all. I might be several hours late. So, yep, that's that then. See you next time.